learned about Gibbs free energy, which basically determined whether or not a reaction was going to be spontaneous, meaning could it occur without any net input of energy. In this video, we're going to talk about chemical kinetics, which has to do with the rate at which a reaction will occur. So the rate can be defined in one of two ways. It can be defined as the changing concentration of reactant over time, which is going to have a negative value because your concentration is going to go down as product is formed. The other way you can look at it is the change in product concentration over time, which is going to increase, assuming the reactants, everything's in the reactant phase at the beginning. So we can define the rate as going to be equal to some constant value times our reactant concentrations. Now, the higher the concentration of our reactants, the more probable it is for collisions to occur in a way that a chemical reaction can proceed. But sometimes these reactants have different impacts on the rate. So we're going to define their impact in terms of something called order. So reactants can be defined as being zero order, meaning that they don't actually have any impact on the rate. They can be first order, which means whatever change you make to the concentration, it's going to have that same exact impact on the rate. Or something can be second order, whereas like if you double the concentration of that reactant and you hold everything else constant, the rate would then quadruple. So it would essentially have a squared impact on the rate of the reaction. So let's take a look at this table right here. And you can see that in experiment 1 and experiment 2, the rate of reactant B would be held constant. It has the same concentration in both situations. And our initial concentration, you can see, of reactant A is doubled from experiment 1 to experiment 2. So essentially this lets us just look at the impact of the concentration of reactant A on the rate of the reaction. And we can see that when we double the concentration of A, we see that the rate doubles. So since it has the same impact, increase in the concentration has the exact same impact on the rate, we would say that this reaction is first order, and we would designate that with an exponent of 1 right there for reactant A. Then we could take a look at reactant B's concentration, and well, when you change it, what kind of impact does that have on the rate of the reaction, and we'll determine the order for that as well. You can see that in experiments 1 and 3, the concentration of reactant A is held constant, and you can see that reactant B is doubled. And when we compare the rates of those two situations, we can see that doubling the concentration of reactant B had actually no impact on the rate of the reaction. So we would designate that with a value of 0. And that's how we determine orders of reaction.